communities, in Discord, Telegrams, in forums, scrolling through it all to understand how crypto truly operates at its heart. That's why we're all here today, or with all of you guys, the fantastic Nillion community. We're all here now. We're all so excited to have you here with us today. And I know all those watching live and all those watching at home later are going to learn a lot from what you have to say today, Tristan. So if you just introduce yourself, give yourself a bit of a background of how you got into Nillion and how you got involved with it and that kind of stuff.
Yeah, so I know there's a lot of questions, so I'll be quick because that was already a pretty good intro. But as you said, my background is in computer science and some design thinking stuff. And then, in crypto as an investor for a long time and working in it full time for now almost 2 years. But built some side projects as well. And I got into Nillion just kind of by chance. I was working at a DeFi company and ran into Andrew Santo at NFT NYC, the conference last year. And we were trading stories, and he told me about this thing that he had just done the due diligence trip for. And he said, if you have these nodes, they can do computation on the data with no messages. I said, that sounds like magic, that's fake. You got scammed, man. And then we started talking more, and we looked into the math and what it would actually be like. And I'm like, wow, this is crazy. And came on board and I've been getting more and more involved every day.
Amazing. Yeah, it's been a truly wild ride. I've only been involved since December, but still so much has changed since then. Even after reading the white paper, it's pretty hard to wrap your head around just how crazy this technology is. And I guess that's why so many people are always asking us questions of how this works, which is just crazy. But if you guys have any questions, you can always just put your hand up as well. There's a little requests function, and then I'll invite you guys up on stage to ask you questions yourself. I know lots of people did have questions, but if not, I'm just going to go through our AMA chat and read off some of the questions that you guys have already posted. So whilst we're waiting for some requests to come through, I'm just going to start off with that. I'm just going to ask one of the questions that we've already had come through. This one is a bit of a big one, so strap yourself in for it, Tristan, because it's a bit big. So this one is from Farius. So he said, this question is a bit complicated. That's why I created an additional image, and I think you've already seen the image, to explain the problem. When we talk about Nillion, talk about post-quantum, so the assumption I make here is that every HTTP message is plain text. Let's assume that I want to know all messages from a specific dealer node. Would it suffice if I observe all messages that go from the Nillion network to the dealer and vice versa? In this case, get all shared and therefore the secret, and can unmask all data. This could be considered a front door attack, but let's think this further. Assuming we can find all the NMC nodes, then we can set up a sniffing border around all NMC nodes and observe all messages that are exchanged between the NMC node and the dealer/result nodes. This would render the Nillion network irrelevant, as I know all data in plain text as well as their senders, and that without infiltrating the whole network. If this argument is it's very difficult to set up this sniffing border, or that the HTTP message are encrypted, then I ask, what additional benefit Nillion brings to the table other than making it a bit more complicated than intercepting a peer-to-peer communication?
Yeah, is indeed a doozy of a question. Let me take a look at it again. So I have it here. I'll post in the AMA chat the picture that I believe goes with this question. So to rephrase the question for you guys, basically the way that I understand this question at least is essentially kind of front door attacks, backdoor attacks, and especially like front door and channel attacks, which is to say attacks where instead of trying to figure out what's happening in the system, in any individual node, what if people are listening in, putting the lines, if you think of a spy movie analogy, to the user who is using the Nilian network connecting to it, or to all of the nodes within the network. I want to put back on just a little bit of the framing of the question, where it says, when we talk about Nilian, we talk about post-quantum. That is, in my mind at least, absolutely not the most interesting thing about Nilian. I think that it is, and we'll get into like kind of my answers to that, but I do want to frame that is not kind of what I think is the coolest stuff about Nilian. I think the coolest stuff is more akin to, well, I think there's a lot of factors, but more akin to like the fully homomorphic encryption style stuff, where it's like, hey, you can have completely private, secure storage and compute on that data, and train machine learning models on it potentially, really do some interesting stuff without ever reconstructing it. But to get there, this is a security question first and foremost, and it's just maybe a bit focused to quantum security, but I think worth going into. And my answer to this question is kind of twofold. So one, like, there is obviously going to be, like, we're not going to not use encryption. It's just, there are two, like, there's two different kinds of encryption that we're thinking about. There's one where we can just use, as exists today, quantum computers aren't there, normal encryption for use cases that don't require the quantum proof, or if they don't care about that stuff. And then there are actually other ways of doing encryption in ITS secure ways, like using, more one-time padding, or one-time padding one more time rather, or ITS MAC addressing. So that, like, we're not reinventing the wheel with the ITS MAC addressing stuff. There's definitely already some research on this of like, how do you create ITS secure channels? There are some, like, they're basically continuously adding to, if you think about Nilian protocol, the Nilian protocol is like NMC as the core. This is a question that's not about NMC. This is a question that's about the Nilian network, which is totally very important. But these pieces of encryption, as far as how do we do message passing, are outside of the scope of NMC, and I want to kind of make that clear. But to answer the question, like, there are ITS secure ways of doing this. So the two that we're thinking of are one-time padding and ITS MAC. And then for really secure use cases, for example, like a decentralized custodian for crypto keys, you can actually do something where, imagine you have 10 shares. So you have your blinding factors, and they get split out into 10 shares that are actually in the Nilian network. And you set a threshold of, you need 5 of them to get, your shares back together. And you actually keep one of the shares. So there's actually 11 total shares. One of them is kept locally. And when you recall from the system, you actually recall 4 shares. You don't recall all 11. So that makes sure that you don't have to set the threshold so high that there's no redundancy on the network, but you still only get enough shares that it's completely impossible, because of, it's still hidden in the polynomial, that they can ever find it, because you actually keep a piece of that share locally. Like, we're not necessarily planning to do that for every use case. This is kind of, at the end of the day, we're a platform, right? So we're a set of tools that we can give to, users and builders like that. And how exactly that develops depends on, our founding engineers and the users we're talking to. But it was a great question. And I see that you're in here, so I'll get to the other questions first. But if you want to come around to it again, Luciferius, please put it in the chat or whatever.
Amazing. You have been hit with some absolute doozies of some questions, to be fair. This is not they've not started easy on you at all. So we're going to go into another one, and it kind of links into what you're saying with the quantum. So this question is from Borg, and he says, I've seen more than one Nilian presentation where the founders suggest that Nilian is immune to quantum attacks, which allows breaking asymmetric encryption private keys, I assume using Shor's algorithm. And the example given is that a private key is stored in the network using information theoretic security. This means that the private key is stored separately in the nodes, and that the nodes don't have the complete information. It is impossible to put the key back together. However, this seems a bit contradictory, because it is assumed that the attacker will try to find the private key by breaking information theoretic security, which is unbreakable since attackers never hold all the data. To discover a private key using quantum attacks, one only needs to know the public key, which is obviously already public. So how does storing a private key in Nillion network solve anything?
Sure, another great question. Another great question, honestly, the answer to it is kind of couched into the first answer I had to that first question, which is, again, I just want to put forth that quantum is not our like number one positioning. It's just because we get it for free with SMPC. Like it's, well, not for free. I mean, we're working on it to make sure that we are like we want to be the most secure that there ever was, and quantum is part of that. But the reason, like what this question is getting at, to rephrase for people who maybe didn't get it fully, is one of the use cases we talk about is crypto private key storage and being able to store a private key in the network in a way that nobody can access it and still be able to compute with it, which is to say like sign transactions, send transactions. And they're asking, well, why would you need to do that if there was quantum? And the answer to that is, yeah, for sure. If there's a quantum break and Shor's algorithm is destroying RSA and all these other quantum all other encryption algorithms that are used to, uphold so much of the world and basically almost all of crypto, that's not going to be any help. But that use case is not built for the quantum world. That use case is built for, people who want to store, for example, Ethereum private. We're not talking about Nillion private keys. Like Nillion authentication is ITS. We have that math has been like completely recently audited, and well, I can get into this later. But for example, if somebody wanted to store Ethereum or Solana or any other blockchain, or even just a password that like they're using, or PGP or whatever it is, keys, like we are not, that's just somebody using our network for the underlying purpose of storage and computation. We can't really speak to the like sanctity of the actual cryptography that people are storing into our system. That's not our problem. And I think we can actually be a solution to a lot of that problem, honestly, in cool ways. But yeah, I mean, this question makes a lot of sense to me, but the answer to it is maybe a little unsatisfying, which is that, this is about public and private keys because that's like a current use case that is really important to people. And yeah, I mean, if Shor's algorithm breaks quantum and, all encryption is dead or all like Ethereum private keys are findable from public keys, Nillion's not going to save you in that instance, unless you were using Nillion for authentication.
Always got to hit them with the plug at the end.
You know how it is.
You've got to pay those bills. Okay, that was fantastic. And the response so far has been insane. Haynes said, the quality of this AMA so far is high. Thought I was listening to the chief engineer, then realized it was only the question. So,
for real, yeah, these are some tough questions, but glad to field it, honestly, and I'm glad we built out a community that's interested in engaging at this level.
Yeah, it's really incredible. Another question from Kelster is, there are big claims made here. Doing general computation on shared secrets without interaction for each multiplication would be a major breakthrough in secure multi-party computation. How come your paper has not been published in credible venues in cryptographic research, crypto/Eurocrypt, for example?
So this is a great question, and I kind of appreciate where it's coming from, which is like academia first, but that's not how we are rolling it out. This is a really new, like NMC is the brainchild of Miguel and is really a new kind of thing, and Nillion formed almost organically around it. And there's a yellow paper being worked on in the background that goes deep into the math, and that's what's going to lead to the publications in academic journals. But internally, we've already had this math audited by Royal Holloway at the University of London, and we're pulling in, actually, so if you guys know any, we're pulling in mathematicians as fast as we can to try and build out new cool primitives on top of NMC. But NMC itself, and more recently, the kind of authentication algorithm we use that's based on NMC, are like fully audited by multiple cryptographers. It's just that we haven't gotten around to publishing it because, I mean, honestly, we'll give it to you guys before we go to the papers. Like the yellow paper will come first, which is what goes deep into the math. And that's what's going to turn into what becomes kind of a academic published paper. So I guess the core of that answer is you're still early. That's why.
Yeah, exactly. That's something that we keep hitting home. It's just how early people are still to this project. It's absolutely crazy. And you just kind of answered another question that we got today that said, could you go further into details on the multi-factor authentication that will be used to secure the user's accounts? The system will only be as secure as the data authentication layer. Previous answers were too vague, but if there are no concrete plans yet, that's understandable. Where can someone dive into the math so we can verify this system is viable?
Yeah, so again, as I said, like the math has been verified, but not by you, I guess. The yellow paper is coming out, and the authentication math is kind of hot off the presses in the last couple months. And that's like kind of when we finally got it like fully vacuum steel box audited by the mathematicians. So that will probably be included in the yellow paper as it comes out, but because it's done. But I hear kind of two parts of this question is the authentication algorithm itself, which is based on NMC. So if you understand how NMC works, you might be able to make some of the logical jumps as to how it gets to authentication. But otherwise, I guess my answer is more wait for the details on exactly how it goes into it. And then I hear another side of that question, which is like the factors themselves. And that's still an open question. We're still kind of designing how much kind of security we want to allow any individual product that builds on us or whatever to use, because we want to make sure that anybody who uses Nilian is keeping their data like it is promised a certain amount of security, because we can create the best secure storage and computation layer in the world, and if a product builds on top of us and then they use unsalted, unhashed plain passwords stored on a single server to access it for their users, that's like going to be bad. So we definitely are thinking about the factors themselves and kind of what will be required to come and interact with the network.
Perfect. This is a maybe slightly easier question. Maybe. It's from Aro. It says, what is it meant when it said that the NIL DAO will assign DDS to full nodes based on subjective, in quotations, factors? Maybe an example of one of the subjective factors will help.
So the DAO health score, the DHS, so I'm kind of a DAO nerd. So for me, it's cool just because I think that it is something that differentiates us, not from every crypto like kind of network and middleware layer out there, but a fair chunk of them, which is that the DAO actually plays a pretty significant role in the running of the network, which is to say this DAO health score is a reputation system that's based on, well, at first, we'll have our own ideas of it, but that's also kind of up to the DAO. But things like how known are the individuals to the DAO, how like even things like latency, the DAO can set kind of subjective parameters of like, well, should people get slashed if they're offline for, a single ping, or should people get slashed if, or should that be allowable because we have a lot of redundancy in the network as long as they're back online within X computations or what have you. I mean, we'll have sane defaults for this, but the goal is to really let the DAO over time in the process of decentralization kind of pick up the mantle and move towards that fully decentralized ethos.
Perfect. I hope that answers the question for you. We've just had a new question roll in. He says he's sorry that he doesn't have his mic on right now, but he was wondering, obviously users will need some information which allows them to reconstruct their data from Nilian nodes. How is that information secured?
So this ties pretty directly into a couple questions ago when I was talking about factors. Like when you think about multi-factor authentication, right, for people who aren't familiar, it's like one factor, for example, a username and a password, right? Those are both, well, username can be public, but imagine they're both private. Those are both factors, right? where you need to know both of those things to get in. And now multi-factor authentication is more about having multiple factors, where you'd imagine that it's better security if those things aren't to each other. If you can get somebody's 2 secret passwords because they keep their passwords in the same place, that's not as good. But if you're forced to, which is like a big thing that is like push that's happening, even in the last weeks with a lot of the big tech companies, to have your physical phone and have an authentication app on there, that's like a better factor when you pair it with a password or email access or whatever it is. So the question is like, what is the information needed? What are those factors, as I understand it, at least? And that, as I said, is still an open question, but we're definitely like very keyed into what is good security on the one hand, and also kind of what is good UX on the other hand. So one thing we want to avoid is we want to avoid the current pitfalls that we see, at least with crypto projects that have a single kind of, lose this and you're dead seed phrase, mnemonic, private key, whatever it is. So we do want ways, and probably, one great way, it's just that people don't necessarily fully have the technology. It's not the technology isn't there, but rather the availability isn't there yet to everyone. But biometric is really one of the best ways to do this in our mind. And we're very keyed into that because one of our founding entrepreneurs is kind of in that space. So there are many ways we can do this. The factors are an open question, but we will, no matter what we do, set that it will be in our eyes secure, and it hopefully will be the goal is that the information on the user side, like we don't want you to be having to store new information that you're like something equivalent to a password as much as possible.
That makes sense. I hope that answered the question for you, which is good, which is perfect. We're still getting them raining in, and still got some going through if you're happy. Someone might ask, what's an example of a computation that would be done on a piece of data that has been split using Nillian's secure multi-party computation method on someone's CPU?
Yeah, so honestly, this is just kind of a use case question, but use case as pertains specifically to computation, if I'm understanding. And so I think that there's a lot. I think you can pick a lot of verticals. One of the things that gets people excited, and kind of how we've pulled a lot of the people that we have in our team out of retirement, like Conrad, is that it has potential implications in a lot of spaces that are outside of crypto, as well as in crypto. And I think maybe some obvious implications inside of crypto. I think the most obvious one, and this is why we use it as the simple example, which despite what the question before about it not being a good quantum example because it implies public and private keys, is signing transactions. So being able to send a transaction, which is, I want to send 1 Ether to my friend, this is his address, and sending that to the Nillian network, and them and me being authenticated, so authenticating with the Nillian network, them knowing it's me, sending that in, and then having it signed by my private key without the private key to any of them, or, and this is actually really interesting, or to you. So the private key to no one is ever reconstructed. That's a form of computation, but it's a fairly basic form of computation. If you want to get into kind of more interesting use cases, potentially, I think it's cooler to go outside of crypto. These are phase 3 use cases for us, if you've read the white paper. A little bit further out, but we're already getting a lot of bites where people are talking to us every day, where, even in the chat here, I see somebody was like, hey, can we use this for real estate? Like, yeah, probably. Those are things like training machine learning models on top of data that people can't access. So you can imagine for medicine that would have a large impact, things like genomics, things like doing studies on hidden data. And you can actually, there's mathematically ways to prove differential privacy. And differential privacy is the concept that if you have a bunch of these pieces, data points, say you know something about 100 people, provable differential privacy would prove that if you do something on all these people, like for example, get the average of a piece of information about them, get their average age. Differential privacy would show, like being able to prove it would mean that you can know that the information that came out without knowing what, like the prover doesn't need to know what the algorithm was, but it knows that the thing that came out was, well, okay, sometimes it does need to know the algorithm is, but that's an aside. The thing that came out is like not pointing to a specific piece of information inside of that data set, which has a lot of implications. I mean, I was saying in medicine, but even, I mean, you can think about kind of the more nefarious ways that data gets used today for advertising tracking, or just a lot of industries where it would be, there are companies who would love to be able to use data, and there are very good there's for good reason regulation that wants to keep data secure. And what this gives, what NMC can give kind of that, and that computation layer on that split up data can give people, is the ability to make sure that the data is provably only being used in ways that it should, and not in more nefarious ways. And that no more people than the ones who are supposed to be seeing it are seeing it, if at all.
Amazing. Yeah, I think you more than answered that question. You did absolutely perfect. And we've got some people that are wanting to come up on stage and ask the questions, if that is all good with you. So I'm just going to invite Blaine up on stage now, if you're ready, Blaine, and you can now come up and speak. There you go. You've just been invited. You've just accepted. There we go.
What's up, Blaine?
If you can...
You're muted. If that's
yeah.
thing of it.
How's that? Is that better?
Yep.
Okay, good evening, gentlemen. Thank you for everything. I'm obviously a little bit grey behind the ears. I'm 62 years old, but I used to be a compact fiber engineer, so maybe I don't have all the terminology that you have. I'm really excited for the project. One of my sort of theories, or just voicing out, is regarding your sharding and everything. I can understand how Ninian has probably secured a lot of its networking. Well, what about the vulnerability once it's given it to someone else or to developers? Is there any sort of technology nowadays that you could have, like a reverse sharding, that should that information get taken off that network, it automatically destroys itself? I don't know if my language is Chinese or not.
So,
I'm looking more. Sorry, carry on.
So one question I would just love to dig in. I think I have an answer for you, but when you say off that network, what do you mean? So if you can think about Nilian as, like, let's say we have 1,000 nodes. When you say network, do you mean all 1,000 of the nodes, or do you mean like the physical networking cabling between them, and like that kind of, as the person before was talking about, like channel attacks?
I think you could do probably both. You could segment it down to, if you gave your information like private keys. From what I read from your white paper, you have primary nodes and secondary nodes. Is that correct?
We call them light nodes and full nodes, but sure. Yeah.
Okay. So obviously within that sector, they'll have identifiers. And all I'm saying is, outside, would it be a possibility of saying if that got hacked and removed, that it automatically destroyed itself because the node identifier was missing?
So that is an
and
interesting...
And basically the hacker just...
I think I hear what you're getting at, and to rephrase it, if I'm understanding correctly, I mean, I think it's a little twofold. It's one, talking about kind of the security of the system on all of these, if it gets taken off of them, all of these individual nodes, and then also, if it does do that, is there some way to make it kind of destroy itself, or is that right? That's
correct. I'm sorry, I'm talking Japanese. I told you I was 62.
No. You're. I just wanted to make sure I was understanding your question correctly. So yeah, I think to answer the first question, which is the security, and I think it speaks into the second question, the whole idea, and I think that this is why there are some people who question why this is a Web3 project. Like, why are we using tokenization at all? Why are we, like, the NMC core tech is good enough that we can build just that, not build the network around it, not kind of try to do this public utility thing, and not play in Web3 at all, and maybe go and sell it as a service to large tech companies, healthcare, whatever it is, governments. And there is some maybe ideological ethos that goes why this is happening this way, but there's also kind of, to speak to exactly what you're talking about, a fundamental security advantage to making it extremely difficult to have all of the pieces of data, like to collude at scale in such a way, which is what kind of decentralized networks are all about. That's what decentralization is, or one of the things decentralization is all about, right? Is the ask is that even if you take, to speak to your second question, if one of the nodes gets fully compromised, or if, even a third of the nodes, or almost a third of the nodes get fully compromised, and all the data gets cleaned out, and you have active adversaries who are in there sending fake data, or like talking to each other and colluding, or whatever it is, that will still be secure. And there's no need to delete the data when it gets taken off of the nodes, because the data that they've taken, they might as well have just opened up their terminal shell and started a random number generator, because they have no more information when they kind of own that machine than they did when they started. That's the true meaning of information. Like, that's what information theoretic security is the probability, if you have T amount of information, or you have, whatever, we can just say X amount of information about something, it's information theoretic secure if that's the same as if you just had no information about the thing. And so we can say that, Nillion is ITS up to a pretty high standard, such that it requires such mass collusion that we don't need to delete the data when it comes off these nodes, because the data is completely meaningless until you put so many pieces together that it would be, financially and just coordinating wise, very, 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 very improbable. Does that answer your question?
Yeah, it does. Obviously, I'm not knowing your future things, but are you saying that even if you go to the governments and say the Ministry of Defense, that always they have to come to your nodes, or are they going to have their own copy, this is where I was getting at, on their own servers?
Oh, so there's two different kinds of information in that's a different and interesting question. There's two different kinds of information in the network, right? There's shares, and shares are used are what we call the blinding factors. Okay, well, let's go back a little bit. I'm sure many of you this may be, if you've read through the white paper a few times, a little bit of review. But at the base level, you have a secret, right? The dealer has a secret. And then that secret gets mixed up and jumbled in an ITS secure way with something we call blinding factors. And the blinding factor is the data that is used to mask and muddle, or as we call it, pad, that information. And that blinding factor is split out into shares using something called linear secret sharing. And those shares are all meaningless without T+1 is the way that it's said in cryptography. And those are split among the nodes. And then the secret is jumbled with that. And then that thing that is made, that is the jumbled secret plus blinding factors, is called particle. And that is also put on, nodes. And the question was, will the government, whoever, if a big tech company or a sovereign nation or whoever, or Ethereum Foundation, who cares, calls us today and says, hey, we want to use Nillion, how do we kind of have as much ownership as we can over the network? There's actually a lot of ways that we can integrate them. And that's, I will say, a bit of an open question of how much into the network do we want to let them? There's a core of security that we need to keep. And then also there's a very much an importance to us in making sure that we're maintaining value accrual in sustainable ways to the network and the token. But yeah, it is very possible for those organizations to, one, participate in the network by running full nodes, and the shares will probably never won't be stored locally. Otherwise, what's the point? I mean, basically at that point, they're just leasing NMC as like a technology from us. They're not using Nillion, but they can elect, or we could allow them to elect, and it doesn't really harm the network much, to let them store the particles, which is to say the jumbled up data of their own secrets. And then the blinding factors are what is kind of like stored out in the network in ways where like even they internally can't put them together without having the proper authentication level, which is actually pretty good, because that's a big vector for attack for like kind of larger coordinated organizations. Is like, if somebody has an off level that they don't necessarily have the off level for a piece of information, but they can like make attacks in certain ways. They might get access to information they shouldn't have. You see this all the time in tech companies where it's like, an IT guy or, somebody on a different team, even internally, like non-maliciously, will create large problems because they had too much authority over like deleting, something that was running live in production on a server or whatever. I can't say that we'll fix that specific problem, but that kind of like authentication, authorization level problems that we can help with when it comes to data security.
Thank you very much. I'm sorry for the simple questions. Thank you very much.
Okay, I'll just move you back into the audience. And I feel like the simple questions are some of the most effective, because we get a lot of the early parts of the paper asked quite a lot because it is so hard to understand, isn't it? So the simple questions are fantastic. But we do have someone else that wants to come up on stage, Luciferius. So I'm just going to invite you up onto the stage now. You've been invited up to speak, and you can come up and ask your question.
Okay, hi. Yes, my question is a bit more use case specific. What you're saying is in the network, I can run computations on the data, but that's not really what I want. What I would want is a part of the data, but what I'm interested is, can I create from the network new data or new messages, you could say? So the use case I have in mind is that you have a dealer node that's putting data into the Nillion network, and then in the Nillion network you have some kind of router who sends this data to a result node in a way that the dealer doesn't know the result node, and the result node doesn't know the dealer, and the Nillion network obviously doesn't know the data, so the data is transferred without each party knowing each other, and that in a secure way. Is that a possibility?
So one little question I have about that is like the dealer, the one part at the end there where you said the result node doesn't know the dealer, that makes sense to me. The dealer doesn't know the result node, that also makes sense to me. That last part about the nodes not knowing either side, I mean, at the end of the day, they have to send kind of a message they have to receive a message from someone and send a message to someone. Although I will say we could obfuscate the either side of that, and I guess that's still an open question, but that would have latency issues, and isn't security through obscurity anyway. But it's more about making sure there's a complete disconnect between the result and the dealer. Am I understanding correctly?
Yes, it's only that the result, that the dealer doesn't know the result node. Obviously, the router needs to know both sides, but the dealer doesn't know the data that is transferred. So the router doesn't know the data that is transferred.
Yes.
And the dealer doesn't know the result node doesn't know the dealer, but both know the data because they can reconstruct it. Yeah.
So I think one way to hopefully everyone got that, but just to put it in other terms, you can tell me if I'm wrong about this, but like as a toy example, one use case I could think of for something like this is something like a VPN, right? Where a dealer is trying to get to a version of a very simple, it's not a very good VPN, but trying to get to, a website, and that website is secured on 5 different servers, and they don't want to know which server, or they can't know which server they're connecting to. And it goes through the network, through the router, as you call it, in the network, and it gets connected to, within Nillion, one of those 5 servers, and they don't know, the placement of the dealer, but they get the message. And then maybe, vice versa. That's like one simple toy example that just came to mind for a use case like this. And my answer to that is yes, but the computation that needs to, you said, that's not what you want to do is computation, but functionally that's still processing, right? And the processing that needs to happen there, that the dealer sends a message, let's say hello world, into the network, but it also, in the network, has a MPP, multi-party, which is what we call kind of hidden executables that are within the Nillion network and ways that you can program the Nillion network. And so this is, again, going to be a phase 2 or phase 3 use case, but there will be like an executable you can think of somewhere within the network, and the nodes all execute that. And within that, there will be instructions. So they'll send it with no result node, and within they'll expect kind of as a callback. If you're familiar with that kind of programming, they'll expect like as a callback, part of the response that they're going to get out is going to be a clear text response about who the result node is supposed to be. Does that make sense to you as like an answer of how that would work?
Well, if I understand correctly, then the dealer doesn't know the result node, right?
No. So okay. So the question is more so exactly in this VPN use case, right? Say there's like 5 servers, and it wants to pick one of the 5 servers. The expectation as I like here is that the dealer connects to the NMC network. There's a multi-party program within the NMC network that doesn't like the dealer sends the message and no result node. And the expectation of this multi-party program is that it will output a clear text result node that the NMC network understands and can send the message that is garbled out to. That should be possible. I think that is like a specific use case that would need to be programmed in, but yeah, I see no reason why within the like confines of the network, like that's not outside of our capabilities. And in that case, the dealer doesn't know, right? Because the hidden, this is another piece of it, right? That multi-party program is also particleized. That multi-party program is kind of particleized. The problem is, and this is the question, and I actually think this is the key of the question, and we'd have to look into it more. We haven't thought deeply about this, but how do we get that like clear text result node address, let's say, like an IP address, for example, from the particleized form of these MPPs? It must be like my intuition is that it's possible, but I can't say it must be. And it's an interesting question. But if we take it more simply, and we take a single random variable for our VPN example, and you have a public array of 5 IP addresses, like a list of these 5 addresses, and those are public in the NMC network, so they're visible. But the number, like the one that gets chosen, is decided by a random number from the NMC nodes. That should be possible, like without much maneuvering.
Well, what I was thinking more is like the message the node sent contains some kind of information about what it is. So let's say the message says, I am a message about the weather today. And then you have, at one point, the result nodes, or the servers in this use case, was set up in a way that they said, well, I want to receive all messages about the weather. And so you have stored some kind of, well, let's call it a dictionary, where you say, okay, I get a message about weather, and these are the receivers of weather messages. And but this information, who are the receivers of weather messages, this must be hidden.
Yeah, so I think that so this is more like a content addressed network, if I'm understanding, where
yes.
And yeah, I think should be possible, because if you think about it from the dealer putting something into, so I guess a message is maybe not how I would phrase that. I think to put it, and tell me if I'm getting this wrong, but another way to phrase it that I'm thinking of is more like you are putting a piece of information like the weather into the network, and it's particleized. Nobody knows the weather, so that they don't, for example, know where you are. And other people are like, the result nodes, or they wouldn't be result nodes in this case, they'd just be other dealer nodes, but they ping to the network. We want all of the information that is kind of like, we want the content that fits within these bounds, in this case, the weather, everything that pertains to that. And that will like get sent to them, because they can do some content addressing within the network. Like the network will have its own content addressing system, and we might need to build a tags system or something on top of it for like deep functionality of the use case you're talking about. But if I understand it, I think we get most of it for free. The big question mark for me is, which is not really a question mark, but it's, do you want the result to, like, you want the people who receive the result to be able to see the full clear text, right? It can go probably either way, but I'm just curious.
Yes, they have to see the full data in this case. And I was thinking about messages and routers, because I also thought about the idea you presented right now. But in this case, the nodes that want to receive the weather information would have to poll constantly to see if there are new information available. In the case,
okay.
If you have messages and routers, then it's more like a broadcast.
You want a push system. Yeah, I mean, again, could that be built within the network? That, from how I understand your framing of it, I absolutely think that could be built on the network. Now, a more interesting question is, because that isn't, like, that would require, if we talk about the Nilian network at large being kind of an NMC core, and then a lot of other pieces like networking and maybe blockchain interoperability connections and all these other things, this would not be like, you probably couldn't do this fully from just an MPP without having a lot of information kind of in there, because the push, no, I actually think you could. It depends on, you'd have to keep a registry in, like, for example, this VPN example, or the weather example rather. There's 5 consumers of the weather and 1 person who puts up the weather, and they want to push the 5 consumers. The 5 consumers will have needed at some point to be registered in a list somewhere that they want this, and there needs to be a push of this information to them. And like when the person who's uploading the weather uploads it, part of the MPP that gets called will just be to send that information to this kind of subscribe feed, this RSS feed of people who want this information. But yeah, I mean, I think a lot of it we get for free, but what I'm hearing as like kind of the core feature that could really enable some of the use cases you're talking about is like a little bit more control to the users of Nilian of the addressing system, rather than and like kind of having a subscribe and broadcast feature, which is what you're getting at, I think.
Yeah, that's exactly what I was.
Whether it's possible or not, like the answer to me, at least on first pass, is like, yeah, it's definitely possible. It's just there's a small feature that kind of needs to be. Well, I don't know how small. I won't speak to the implementation, but there is a feature. Like most of it we get for free, but potentially we may need to build like a kind of a stronger tagging system on top of messaging.
Okay, thanks. It would be totally amazing if this kind of thing works, because the idea I have in mind is it's quite amazing in the context of my work that I do daily.
Hey, we are always looking for founding engineers, so shoot us an email at founding@nilian.com, and we'd be happy to talk about it.
Sure, we'll do.
Thanks.
Thank you very much. That was That was big. There's a lot of stuff. We're going to end on just one more question now, and then we'll do some closing notes, and then we'll be sorted. So the last question is just rolled in. It says, if/when Nillion gets to the level of Bitcoin or Ethereum scaling-wise, what will be the environmental impact? Will maintaining the whole database be energy hungry like the proof of stake consensus mechanism?
So the framing of this, I want to believe when you say proof of stake here, you mean proof of work. Partially selfishly, because we are definitely also going to have a somewhat proof of stake system. Yeah. So no, yeah, definitely it's more into a proof of stake system, and it's relatively efficient. I think the thing you would compare it to, right, or the thing I am going to compare it to rather, is a server, like just kind of a centralized server, AWS style situation for doing computation, storing stuff, whatever. We do lose from an environmental perspective some efficiency because you're involving more machines, but it's not even on the scale of like standard proof of stake for computation. Like when you run a smart contract on what are considered to be environmentally kind of, forward-thinking chains, they are still running generally, unless there's like some forms of sharding, which can mitigate this. But for most of the chains that are doing this, where sharding is kind of not really implemented, all of the validators in those sets are still running all of it. Whereas because the way Nillion works allows kind of subsets of the network to be storing and computing on stuff, you're actually using less than the computations on like a blockchain of kind of, that works also on like a proof of stake style system, or that works with staking. Let's say we're not really a proof of stake system, but we will have kind of financial incentivization of the same variety.
Amazing. Perfect. That was our last question. Because we're coming close to the hour now. I think this AMH just proved we have a very technical community, which is, something that we've had in mind from the beginning, isn't it, really? To cultivate a community that is looking to build on top of Nillion at some point in the future. And I just like to say thank you to Tristan from myself, the team, and everyone for taking time out of your busy day to come and answer these questions for everyone. I know it's been massively appreciated, and this has been massively helpful for those who have just watched everything and are continually scratching their heads. This is all being recorded and will be uploaded again tomorrow for everyone to watch. So we'll get that all sorted. But yes, thank you very, very much, Tristan, for coming on with us today. It has been a real pleasure.
Yeah, thanks. It was a pleasure, everyone. Cheers.
Cheers, guys. Take care. We're going to close down the stage now, and everyone can start to leave. Have a great night. Take care, guys. Thank you very much.